All right, so to find the first term, you substitute this number in right here into the formula. That's how they found the first term. Okay, does anybody know by looking at this where the ratio comes from? No?
Maybe -2.
Well, look down here and see what they use for the ratio. You see what they use for the common ratio? Yeah, they use -2. So your ratio comes from the number that's raised to the power. So you're always going to look for the number that's raised to the power. That's going to be your ratio. And then your n is the number of terms that you're going to find. So, and what number did they use here? They used the number 7 here. So you could count these on your finger. I'm putting in the first term, second term, third, fourth, fifth, sixth, seventh. We know there's 7 terms there. But the formula in order to do that says it's the top one minus the bottom one, and then always add 1 to it. So you would get 7 for your number of terms.
Why is that?
Yeah, because what if it doesn't start with 1 right here? That's why. So what if it was 8 up here and 4 down here?
Oh.
Then you have to take into account the one that, yeah.
Yeah, I thought you everything was like, what's confused?
So after you figure those out, you still plug it in the formula and solve it the exact same way. So I know this seems a little bit confusing because it's already done for us. So let's just jump over and do it on our own and see what we can do. Okay, the very first thing I need to do is find my first term. How do I find my first term? I substitute in the first value down here. What's my first value? 1. So I'm going to go 5 times -3 to the 1 minus 1 power. And just yell out an answer for me when you get that. It is 5. Okay, so guess what my first term is? 5. Okay, what's the other thing I need to know? I need to know the common ratio, and I need to know the number of terms. Anybody remember where I said to find the common ratio at? It's the number that's raised to the power. So what's the common ratio? -3. And then the number of terms would be 9 minus 1 plus 1. Again, it's the top minus the bottom plus 1, which in this case is 9. Again, the reason for the formula is because what if this was 300 up here and this was 129? It's just so that you could do it's the top minus the bottom plus 1 to take into account all of those terms. Okay, we're going to rewrite that formula from the other page so that we can substitute into it. And we can do the math to find our sum. So here's my formula. And I'm going to substitute in. So I'm finding the sum of the first 9 terms. My A1 value is 5. My common ratio is a -3. I'm raising that to the number of terms power, which is 9. And then 1 minus the common ratio again, which is a -3. Guys, a lot of extra little negatives and stuff going on here, so be careful when you put that in your calculator. Do you guys remember that always when you raise a negative number to a power, it should be inside parentheses? So make sure you put that in parentheses so you don't get confused as to what that power really should be. When you get this number right here, go ahead and shout it out to me. I have my work done already so we can check it and make sure it's all right. It's big, so don't be afraid to shout it out.
Why are you doing that?
That is right, 24,605. So the sum of the first 9 numbers is 24,605. If you're having trouble on your calculator, I can come help you in a few minutes with that. Okay, couple problems on the back. Again, here's another example. This time instead it says to find the sum of this. We're just going to do one more example like that. And then I need to work that story problem at the bottom. So in order to use my formula, I need my first term, I need my common ratio, and I need my end value, right? Those are the three things I need for my formula. So how do I find my first term? What number am I substituting in? 2. I'm substituting in 2. So I would go 30 times 3/4 to the 2 minus 1 power. Then just punch that in on your calculator and shout it out for me. It's a decimal point number, it's okay. 20, I got 22.5. Did you guys get 22.5?
Holy crap, it's warm.
Okay, your common ratio is what number this time? It's 3/4. I know some of you guys like to look at that as a decimal point number and use 0.75. If you'd rather use 0.75, it's totally fine with me. And then the number of terms would be 9 minus 2 plus 1. So 7 plus 1 is 8. So I'm using 8 for my number of terms. Again, I'm just going to write down that formula so we can plug our stuff into it in the right spots. So I'm going to do the sum of the first 8 numbers of this series. I'm going to have 22.5 times 1 minus the ratio. You want 0.75 or do you want 3/4? 0.75 to the 8th power all over 1 minus 0.75. You're just going to let your calculator do the work on that. Shout it out when you get the answer for me.
No, seriously. What did I do wrong? I did something wrong on A, or the A1, like, 45 over 50.
Well, that's 45 divided by 2 is 22.5.
I got a whole number.
Yeah, she was saying it was. No.
Anybody else get it yet?
Yeah, it's 22.5. I was just wondering, because when she wrote it up there, it was real. No, no.
Okay, decimal but rounded up. You're right, Cameron. Did you get 80.989? And I rounded that on my paper to 81. But you're right, it's 80.989. Okay, questions on how to do that one?
80.9898
Yeah, that pretty much.
So we round it?
Yep. Okay, last problem. Suppose you deposit $200 into a savings account that will earn 2% interest compounded annually. Every year you deposit an additional $200. What amount of your money will your account have after 5 years have passed? Okay. There is a formula for this already. You could actually use the formula that we just did, but I want to just talk about how to do it for hand for just today. So it says you start with $200 and you earn 2% interest compounded annually. So that $200 you would have 2% interest on, right? Does everybody agree with me that 2% of 200 plus the 200 is what I'd have at the end of year one? So what do I have at the end of year one? How much? Good. Do you guys agree that I would start the next year with $204? And I would add 2% of that on at the end of the year? Except for, what did it say that I did? Every year you deposit an additional $200. So if I ended with 200, what do I start with here? 404. And I would do those are fancy fours, huh? So then I would have to do the math with the 404 because I added the extra $200 on. So what do you end up with there? Yep, so that was at the end of year 2. What do I start with at the beginning of year 3? 612.80. Does anybody remember how many times it asked me to do this on the problem? It says after 5 years, right? So we got to do this 5 times. This will be at the end of year 3. Did you get 624.32?
It's supposed to be 0.8, not 0.8.
Oh, did I do it right? I just wrote it wrong. Thank you.
There we
0.8. Thank you for letting me know I wrote it down wrong. Did you get 624.32? All right, what are you starting the next year with then? 824.32?
This is messy.
That would be year 4, so we're almost done.
After 10 years.
It says after 5 years, thank heavens, right?
It's after that. It says after 10 years.
Oh, we're not going to do after 10 years. That was too much work.
Yeah.
What'd you get on this one? I got 840.80. Is that what you guys got? So what'd you start out the last year with we're going to do? 1040.80? And so we would end at year 5 with... Perfect. Okay, we're not going to go further than year 5 today on that. We could go 5 more years, right? It's not really that hard to do.
Can't we just do the formula?
Okay, you figure out how to plug it into the formula, and I say you go for it.
Dang it.
Okay?
I can't remember.
All right. You guys, that's the end of today's note-taking guide. You have the rest of the